Hybridization. Hybridization. Before going to understanding the hybridization, let we know why this hybridization is required. Let's take ammonia CH4. That is, structure of the ammonia is carbon form each pi bond with sigma bond with hydrogen. That is, hydrogen electronic configuration is 1s1, 1 electron in s orbital, and carbon is 1s2, 2s2, 2p2. That is, 2 electron in 1s orbital, 2 electron in 2s orbital, and 2 electron in 2p orbital, which is px and py. Now carbon, according to theoretically carbon has 2 unpaired electrons, but to form ammonia we need 4 unpaired electrons. So for this we make that carbon is excited state. That is, carbon excited state. 1s2, 2s1, 2p3. That 2s orbital, 1 electron is enter into 2p orbital. 2s orbital electron is enter into 2p orbital due to exciting. That is, 1 electron in 2s and 3 electrons in 2p. Whereas px, py and pz, this is 2p. 2p orbital has each electron in the px and py, pz orbitals. Now carbon has 4 unpaired electrons. That is, 1 electron in 2s orbital, other 3 in 2p orbital. Now the bond formed between carbon and hydrogen atoms. That is, excited carbon take only valence electrons only. That is, 2s1 and 2p, whereas px, py, pz 1 electrons, and hydrogen has 4 hydrogens. Let's take each hydrogen 1, hydrogen 2, hydrogen 3 and hydrogen 4. These are the form bonds. whereas these are the 1s1 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 1s1. It means that 2s and 1s form one bond, and 2p and 1s 2p and 1s and 2p and 1s. These are the four bonds formed by ammonia with the carbon with hydrogen in ammonia, whereas one is 2s and 1s, other one is 2p1s 2p1s 2p1s. That is S bond and S and P bonds, S and P bond, S and P bond. We know that according to this, theoretically this 2s and 1s bond has less bond strength than 1s and 2p bond. That is, it has a high bond strength. That was 1s and 2s and 1s and 2p. This type of bond form in ammonia. So by theoretically, but actually its form is bonding. Every bond in the ammonia has the same bond strength. Due to this variation, we proposed the hybridization. Hybridization is make the redistribution of energy in the orbitals. That hybridization make the redistribution of energy in orbitals. That is, carbon as in outermost orbit is at excited state is that 2s1 and 2p3. That is, these are the pi orbital, these are the s orbital. Now we make the hybridization for this 1s orbital and this 3p orbital, which has in the same bond strength in making of ammonia. Make hybridization which make them same energic orbitals. That is 1 2 3 4. After hybridization means making that orbital in same energy. That is, here s orbital has one energy and p orbital one energy. After the making the hybridization, they make all these are the hybrid orbitals. These are the atomic orbitals. After the hybridization, it is s, px, py and pz. These four orbitals has same energy. It happens due to redistribution of energies in orbital by making hybridization. Now the bond formed bond formed in ammonia has same bond strength. That is, we make hybridization between the s orbital and p orbital, which gives hybrid orbit. Sorry. This s orbital and this p orbital. This is hybrid. It is hybrid orbital. Now we get four hybrid orbitals. These are the four hybrid orbital by making s and p orbitals hybridization. Now how the bond form of CH4 is that it is one hybrid orbital and it is other hybrid orbital of excited carbon which form with s and p orbitals, and it is other hybrid orbital. It is other hybrid orbital. These are the carbons. These are the carbon hybrid orbital. 1, 2, 3, 4. These are the four hybrid orbitals of the carbon. And now the hydrogen. This hydrogen has the s orbital which are spherical shape. It is circle. Now these are the shared electrons in opposite swing. This is the hybridization of the CH4 ammonia, which has the same energetic orbitals produced by hybridization of s and p orbital at the excited state of the carbon. Thank you.